Good morning, students. Myself, Dr. T. Sudarshan Ramaperumal, Associate Professor, Department of Electronics and Communication. Today, we are going to see about fog, edge, and cloud computing in IoT. IoT database management stack contains the fog, edge, and cloud computing common. Fog computing to distribute the data management throughout the IoT system as close to edge of the IP network is possible. The best known embedded of edge service is IoT or is fog computing. Any devices with computing, storage, and network connectivity can be a fog node. Examples include in the industrial controllers, switches, routers, embedded servers, and IoT gateways. Fog computing. Analyzing IoT data close to where it is collected, minimizing latency, offloads gigabits of network traffic from the core network. A real-life example of fog computing would be embedded applications on production line where a temperature sensor connected to a edge servers would measure the temperature every single second. This data would then be forwarded to be put application for monitoring of temperature. Characteristics of fog computing: contextual locations awareness and low latency. The fog node sits as close to the IoT endpoint as possible to deliver distributed computing. Geographical distribution: in sharp contrast to the more centralized cloud, the service and application targeted by the fog node demand an widely distributed deployment. Deployment near IoT endpoints. Fog nodes are typically deployed in the presence of large number of IoT endpoints. For example, typical meeting deployments often see 3000 to 4000 nodes per gateway router, which also functions as a fog computing. Characteristics of fog computing: wireless communication between the fog and the IoT endpoints. Although it is possible to connect wired nodes, the advantages of fog are greatest when dealing with the large number of endpoints and wireless access is the easiest way to achieve each scale. Use of real-time interactions. Important fog applications involve real-time interactions rather than the batch processing. Pre-processing of the data in the fog nodes allows upper layer applications to perform batch processing of on subsets of data. Advantages of fog computing in IoT: low latency. Fog tends to be closer to user and can provide a quicker response. There is no problem with bandwidth. Piece of information or read the spread point rather than sent through a channel to single one. Due to many interconnected channels, loss of connection is impossible. High security because of data is processed by multiple nodes in a complex distributed system. Disadvantages of fog computing: fog is additional layer in the more complex system. A data processing and storage system additional expense combines must by edge services, routers, hubs, and gateways. Limited scalability. Fog is not scalable like a cloud. Edge computing. The natural place of fog node is a network device that sits close to the IoT endpoint, and these nodes are typically spread throughout the IoT network. However, in recent years, the concept of IoT computing has been pushed even further the edge, and even some cases it now proceeds directly to the sensors and IoT devices. Edge computing is also sometimes called as mist computing. It clouds exist as sky, the fog sits near the ground, then mist is what actually sits in the ground. Thus, the concept of mist is extended fog to the furthest mind possible, right into the IoT endpoint devices itself. IoT devices and sensors often have constrained resources, however, as compute capability increases. Some new classes of IoT endpoints have even compute capabilities to perform at least low-level analytics and filtering to make base decisions. Example of edge computing: consider a water sensor on a fire hydrant. While a fog node sits on the electrical pole in the distribution of network, may have an excellent view of an fire hydrants in a local neighborhood. A node on each hydrant would have clear view of the water pressure drop on its own line and would be quickly generate on alter of localized problems. Cloud computing, the delivery of on-demand computing services is cloud computing. We may use applications to store and process power over the internet. Without owning any computing interfaces or data centers, anyone can reason access to any time from applications to storage from cloud service providers. Cloud computing technology provides variety of services, infrastructure as a services, platform as a services, software as a services. Infrastructure as a services, a remote data center which data storage capacity, processing power and networking resources. Platform as a service, a development of platform with tools and commons to build, test and launch applications. Software as a service, software tailored to suit various business models. Infrastructure as a service, virtual machine, virtual storage. Platform as a service, Adreno IDE, software library. Software as a service, online image converters, document converters. Advantages of cloud for IoT: improved performance, storage capacity, processing capacity, and low cost. And these are the disadvantages of cloud: high latency, downtime, security, privacy, and difference between the fog and cloud computing. Fog computing data received from IoT device using any protocol, receiving and summarize data from different fog nodes. And this is best structured, and fog is a decentralized architecture where the information is located at different nodes and source close to the user. There are many centralized data centers in the cloud, making it difficult for the users to access information on the networking. And data is received from IoT devices using any protocol, receiving and summarizing data is different fog nodes. Of these decentralized architectures, information is located at different nodes and source close to the user. Fog is more secure system with different protocols and standards. Cloud operates on the internet is more likely to collapse in case of unknown network connection. Fog has some additional features in the addition of the feature provided by the commons of cloud that enhance its storage and performance at the end gateway. Cloud has different pods such as front platforms, backend platforms, and cloud delivery and networks. These are some of the difference between the fog and cloud computing. Thank you.